Hello everyone. In this section, we are going to study the Fourier series. In the practice, we are going to show the cosine function and the sine functions becomes a orthogonal series on the indicated interval of the minus p to the p. So we use the following the trigonometric series. 1. Cosine pi over px, cosine 2 pi over px, cosine 3 pi over px, blah blah blah, and sine function with the sine pi over px, sine 2 pi over px, sine 3 pi over px. We use these trigonometric series as an orthogonal series on the indicated interval of the minus p to the p. We express the general function of the f with a trigonometric series on the interval minus p to the p, and then we call this expansion is a Fourier series. So fx is expressed a sub 0 over 2. This is a constant terms. Plus sigma starting from the I equals 1 to the infinities. A sub I is a coefficient of the cosine functions. Cosine I pi over px. And b sub I is a coefficient of the sine functions. B sub I times sine I pi over px. We are going to find the value of each coefficient. First one is a coefficient a sub 0. How to discover a sub 0? We integrate both sides of the equations on the interval minus p to the p. And the left hand side is a function of f is integrated from the minus p to the p. And the first term on the right hand side is a sub 0, and the 2 is a constant value. It becomes outside of the integrals. And the integral of the 1 minus p to the p, this becomes a 2p. And the 2 is going to be cancelled out. So because of this cancel of the 2, we introduce this a sub 0 over 2. And then if you integrate of the cosine functions, minus p to the p, it becomes 0. And the sine function also becomes 0. From this expression, we discovered a sub 0 can be calculated. 1 over p integral minus p to the p fx dx. This is how to calculate a sub 0. Then we'd like to find out other coefficient, a sub I. We need to multiply the cosine functions, cosine j pi over px, and they integrate the equations on the interval minus p to the p. And the left hand side is a fx times cosine functions, and they integrate minus p to the p. And the right hand side is a first term is a sub 0 over 2 times the cosine functions, integrate. And the integral of the cosine function is a 0. And the second term is inside of the sigma. A sub I is the integral of the product of the cosine function. When the I is not equal to the j, this integral becomes 0. But when the I is equal to the j, it becomes a p. We proved these formulas in the practice. And the product of the sine functions, it becomes a 0. So we use this expression to find out the a sub I. A sub I is expressed 1 over p, and the integrals minus p to the p fx cosine I pi over px dx. Then we'd like to find out the b sub I. To find the b sub I, we need to multiply the sine function both sides of the equations, and they integrate on the interval minus p to the p. And the left hand side becomes the product of the fx and the sine functions, and they integrate minus p to the p. And the right hand side is a constant value of the a sub 0 over 2 becomes outside of the integrals. Integral of the sine function is becomes 0. Product of the cosine function and the sine function, it becomes 0. And the product of the sine function, when the I is not equal to the j, it becomes 0. When the I equals j, it becomes a p. We've also proved these formulas in the practice. Then only the one term is left in the right hand side. So it becomes a bi. Bi is expressed 1 over p and the integral minus p to the p fx times sine I pi over px dx. Using this formula, you can substitute a sub I and b sub I and a sub 0 into this equation. We can express the function of the f using the cosine function and the sine functions. So we express the function of f with a trigonometric series. This is a Fourier series. So in the practice, we find out the Fourier series of the fx. Fx becomes a 0 in the range of the minus pi to the 0. Fx becomes a 1 in the range of the 0 to the pi. This corresponds to the a sub 0 over 2. S sub n is a partial sum of the sine functions. So this corresponds to the b sub I. And a sub I becomes 0 in this case. When n is go to the infinities, this is exactly equal to the Fourier series of the fx using the trigonometric functions. But it is impossible for the n to approach the infinities. So we just only consider the partial sums. So when x is minus pi to the 0, it becomes a 0. And when the x is a 0 to the pi, it becomes a 1. So red line show the fx 0 to the pi, it becomes a 1. If you take a partial sum, so just we only consider the 3 terms. Sum of the 3 terms is the s sub 3. It looks like similar to the fx, function of the fx. We increase the numbers. If you take 8 terms, it becomes very close to the fx. If you increase more, 15 terms, it's almost, you can express the fx increase up to the 100. It's quite similar to the solution of the fx. So by increase the number of terms, we can express the original function of the fx with the computers. So computer has no problem to increase the number of terms to be considered. Then we can express any function using the trigonometric functions. At the point of the discontinuities, at the x equals 0, it becomes 1 over 2. Approach from the negative value of the x becomes a 0. This is 0. Approach the positive value. So x to the positive, it becomes a 1. So 0 plus 1 and divided by the 2 is take average. So it becomes a 1 over 2. So if you consider the Fourier series, functions pass through the midpoint of the each discontinuity quantities. So we studied very important series, Fourier series, in this session. Okay, this is the end of this section.